Alright, today's reading is Training Circular 9237, Operator Circular Welding Theory and Application, May 1993, Headquarters Department Army, Distribution Restriction, Approved for Public Release, Distribution Unlimited. Let's see, 126, I believe is the page number long, it's on 126. Alright, no, we're page 124. Oxyacetylene cutting equipment. Cutting torch and other cutting equipment. The torch, like a welding torch, has a tube of the oxygen, one acetylene. In addition, with a tube of the high pressure oxygen, along with the cutting tip of the nozzle. The tip is provided with a center of the hole through the jet of the pure oxygen passes. Mixed oxygen and acetylene passes through holes surrounded the center of the preheating flames. The number of the orifices in the oxyacetylene ranges from 2 to 6, depending on purpose for which the tip is used. The cutting torch is controlled by a trigger or a lever-operated valve. The cutting torch is furnished with interchangeable tips for cutting thicknesses. Steels less than a quarter inch to more than 12 inches in thickness. So your figure 512 shows the oxyacetylene cutting torch, 75 degrees straight head, rear tube, crossing sectional through head, torch handle, acetylene needle valve and assembly, 90-degree head tip, preheating oxygen tube, preheating acetylene tube, cutting oxygen tube, oxy valve spring trigger assembly, oxy valve and seat, torch handle, oxygen hose connection, acetylene hose connection, acetylene needle valve assembly. Figure 513 shows the diagram of the oxyacetylene cutting torch, oxyacetylene vents, and oxygen vents. Alright, 516, cutting torch and other cutting equipment. A cutting attachment fitted with a welding torch is placed in welding tip shown in figure 514. Figure 514 shows the cutting tip of the welding attachment. It shows the cut 90-degree angle T-hip preheating gas tube, high pressure cutting oxygen tube, cutting oxygen valve there, torch handle, oxygen needle valve, acetylene needle valve, oxygen hose, acetylene hose, and 75 degrees. In order to make a uniform, clean cut on steel plate, motor-driven cutting of the machine is used as a support guide of the torch and cutting torch. Straight line cutting or beveling accomplished by guiding the machine along a straight line or a steel track. Arcs or circles are cut in grinding of the machine with a radius rod provided, pivoted about a center point. Typical cutting machines is an operation shown in figure 515, 516. 515 shows making a bevel, cutting a circular path with a cutting machine, and then 516 shows the making of 4 oxyacetylene circles or cuts. There's a wide variety of cutting tips of the sizes available to suit with the various type of the work. The thickness of the material cut generally governs the selection of the tip of the cutting. Oxygen pressure, cutting speed, preheating intensity should be controlled by the producing narrow parallel side curve. Cuts are improperly made will produce ragged, irregular edges adhering to slag at the bottom of this plate. Figure 513 identifies cutting tips, numbers and gas pressures, hand cutting speeds, and using cutting in mild steels up to 12 inches thick. 513 shows the oxyacetylene cutting torch, the plate thickness, cutting type, tips number, size number, oxygen PSI, acetylene PSI, hand cutting speed. Alright, 517, operation cutting equipment. At the required cutting tip of the torch, adjust the oxygen and acetylene with a pressure in the corner of the table to 5.3. Note the oxygen acetylene gas pressure setting is listed, and the only approximately an actual pressure should be set to affect the best of the metal cut. Adjusting preheating flame to neutral. Hold the torch with the cutting oxygen level. The trigger can be operated with one hand and with the other steady, maintaining position of the torch, head to work. Keep the flame at a 90-degree angle to work over the direction of the travel. The inner cones of the preheating is about 1/16 of an inch above the end of the line to the cut. Hold the position only until the spot has been raised to a bright red heat, and then slowly open the cutting oxygen valve. If the cutting has been started properly, the shower of sparks will fall from the opposite side of the work. Moving the torch at the speed will allow the cutting to continue penetration of the work. A good cut will be clean and narrow. Cutting billets, brown bars, heavy sections, time and gas are saved if a burr is raised with a chisel at the point where the cutting is to start. This small portion will heat quickly and cutting will start immediately. The welding rod can be used to start the cut on heavy sections when used is called starting rod. Alright, Section 3, Arc Welding Equipment and Accessories. General, electrical welding process with an arc produced between the electrical and the work of the piece of the base metal. The arc is formed by passing the current between the electrode of the workpiece across the gap. The current melts the base metal and electrode if the electrode is a consumable type, creating a molten pool, solidifying the weld formally with an alternative methods employ a non-consumable electrode with a glass tungsten rod. In this case, the weld is formed metal and solidifying the base metal at the joint. In some instances, additional metal is required to add into the molten pool from a filler rod. Electrical equipment required with the weld depends on the arc welding depends on the source of which the electrical power is obtained. If the power is obtained with the public utility lines, one or more of the following devices are required: a transformer, for which there are several types, rectifier, motor generators, control equipment. If the public utility power is not available, the power generators driven by gasoline or diesel engines are used. A direct current welding machine has a heavy-duty current generator. This generator is made of 6 standard ratings of the general purpose described below. Machine rating of 150 to 200 amps and 3 to 30 volts are used in light shield metal arc welding, gas metal arc welding. They are used for general purpose job and shop work. Machines rated at 200, 300, 400 amps, 40 volts, used for general welding machine purposes, machine and manual application. Machines rated at 600 amps, 600 amps, 40 volts are used in submerged arc welding and carbon arc welding. For carbon arc welding. Alright, 517 shows a cutaway of the DC welding generator. The electrical motors can commonly use the drive of the welding generators are 220 to 440 volts. 3-phase 60 cycle of the gasoline diesel engine should have the rated horsepower in excess of the rated output of the generator. This would allow the rated overload capacity of the generator, the power required to operate the accessories of the engine. Simple equation horsepower is 1.25 over 745, 746 can be used. Horsepower is used in the engine. The purpose of the P is generated with the rating of the watts. For example, the 20 horsepower engine would be able to use the driven welding generator at 12 kilowatt output. Alright, in most direct current welding machines, the generator is a variable with the voltage type of the range of the voltage automatically adjusted with the demands of the arc. However, the voltage may be set manually with a rheostat. The welding current amperage is also manually adjusted if and set by the means of the selector of the series and plug receptacles. Either case, the desired amperage is obtained by tapping into the generator field coils. When both voltage and amperage of the welding machine is adjusted, the machine is known as a dual control type. Welding machines are manufactured with the current controls maintained with the movement of the brush assembly. Direct current welding machine is described in Technical Manual 53431221115, is illustrated in Figure 518. Alright, starting from voltage and control going clockwise. Engine hour meter, welding voltmeter, and ammeter, battery generator, voltage indicator, oil pressure gauge, engine control switch, throttle control choke, ground cable, terminal, electrode cable, terminal, slave receptacle, circuit breaker, 110 volt AC connectors, polarity switch, welding contactor, receptacle, and current control. A maintenance schedule should be used to be set up with keep the welding machine with a good operation condition. Machine should be thoroughly inspected every 3 months with the blown free of the dust of the dirt and dry and compressed air. At least once every year, the contacts of the motor starter switch and rheostat should be cleaned and replaced if necessary. Brushes should be inspected frequently to see if they are making proper contact with the communicator. They are move freely in the brushes holders. Clean and true communicators. Sandpaper the communicator stone if and burn and roughen. Check the bearings twice a year. Remove all old grease and replace with new grease. Alright, direct current rectifier type of the welding machines have the design for the copper oxide silicone cellium dry plate for the machine usually consists of a transformer to produce the power line voltage to the required 220 over 440 volt 3-phase 60 cycle input current. Reactor adjustment of the current rectifier to change alternating current to direct current. Sometimes other reactors is used to reduce the ripple in the output current. Alright, 520, alternating current arc welding machines. Most alternating current arc welding machines are usable as a single operated with a single transformer, Figure 519. For manual operation industry application, machines have 200, 300, 400 amp ratings are sized in general. Machines with 150 amp ratings are sometimes used in light industry, garage, and job shop weldings. Figure 519 shows alternate current welding machine with a ground cable connector, power cable, welding cable connector, current selector dial. The transformers are generally equipped with the stabilizing capacity of the control of the current control is provided in several ways. One such method is means of an adjustable reactor output circuit for the transformer. The other is the internal reaction for the transformer or adjustable hand wheel, usually installed at the front over the top of the machine to make the continuous adjustment of the output current without steps possible. Screws, bearing, and machines are screw type adjustable, should be lubricated every 3 months. Same lubrication schedule applied with the chain drive, the contact switch, relays, plugs, jacks, connections should be inspected every 3 months, cleaned and replaced as required. Primary input current is no load should be measured, checked once a year for ensure the power factor connection capacitors are working. Input current is specified in the nameplate with the manufacturer's instruction book. Alright, 521, gas tungsten arc equipment, welding equipment, or TIG. Tungsten ignite or TIG welding, also known as GTAW, an arc struck between the virtually non-consumable tungsten electrode workpiece. Heat of the arc causes the edge of the work to melt with the flow together. Filler rod is often required to fill the joint. During the welding operation, welding area shield with the atmosphere, a blanket with the air argon gas. A steady stream of argon passes through the torch, in which pushes the air away from the welding area, preventing oxidation. Electrode weld puddle heat affected zone. B. The basic equipment requirements of the manual of the TIG are shown in Figure 520. Equipment consists of the welding torch plus additional apparatus to supply of electrical power, shield, gas, water, inlet, and outlet. Also, personal protective equipment should be worn to protect the operator and from arc rays during the welding operation. 520. Gas tungsten arc welding setup. You have your torch, you have your argon hose, water inlet hose, torch cable, cable adapter, water outlet hose, and welding cable, water supply, power supply, and welding cable regulator, gas regulator equipment, argon gas supply. Alright, different types of TIG welding equipment are available through normal supply channels. Water-cooled torches, air-cooled torches are both available. Each type of the current type carries different amperage rating with itself with the appropriate manual covering with the type of the torch used. Argon is supplied with a seal cylinder containing approximately 330 cubic feet with the pressure of 2,000 psi. Single two-stage regulator may be used to control the gas flow. Special design with a regulator containing a flow meter is shown in Figure 521. May be used. The flow meter provides a better adjustment V with the flow of the control of the single two-stage regulator calibration in cubic feet per hour. Current flow of the argon of the torch is set by turning the adjusting screw on the regulator. The rate flows depends on the kind of thickness of the metal to be welded. 521 shows the argon regulator with a flow meter pressure gauge adjusting screw. Blanketing of the welding area provided with a steady flow of the argon gas directed for the welding torch. Since argon are slightly more than one-third times as heavy as air, the push of the light air molecules aside effectively preventing oxidation. Welding electrode, molten metal weld pool, and the heat affected zone adjacent weld bead. Figure 522 shows the TIG welding torch shows the tungsten electrode, gas nozzle, orifice, collet, torch handle, electrode cable, water outlet, in hose, and gas hose, water inlet hose. Alright, you're continued. Tremendous heat of the arc with a high current and high current often you usually necessitate water cooling of the torch power cable. The cooling water must be clean. Otherwise, restricted blockage packets may may cause excessive overheating damage of the equipment. Advisable with a suitable water strainer filler at the water supply source. If a self-contained unit is used, such as one used with the field with the surge tank, where water cooling is recirculated with the pump and antifreeze if required. If the unit is to be used outdoors during the winter months and freezing weather. Some TIG welding torches require less than 55 psi water pressure still and will require a water regulator of some type. Check the operator normal use of this information. Alright, your nomenclature of your torch shown in Figure 522. The cap prevents escape of the gas at the top of the torch over the locks of the electrode in place. Collet made of copper electrode fits inside. When the cap is tight and the squeezes against the electrode, leaks it into place. Gap orifice allows the gas to escape. Gas nozzle directs the flue of shielding gas onto the weld pool. Two types of nozzles are used. One of light-duty welding is made of ceramic material. The one heavy-duty welding with the copper water-cooled nozzle. And hoses, 3 plastic hoses connected inside a torch handle carry the water, gas, and electrode power cable. Gas metal arc welding or MIG welding. Gas metal arc welding is commonly referred to as MIG welding. The following text of the MIG welding refer to the gas metal arc welding. MIG welding is a process where the consumable bare wire electrode is fed with a weld of the controlled rate of speed, while a blank of the inert gas shields the welded zone from the atmospheric contamination. In addition, with the three basic types of metal, the transfer will characterize the gas metal arc welding process. There are several variations of significance. Pulse spray welding. Pulse spray welding is a variation of MIG welding process capable of all position welding, high energy level to short circuiting arc weld. Power source provides two current levels, a steady background level to two lows, producing spray transfer, pulse peak current, and superimposed background current with a regulator interval with a pulse peak is always is well above the transition current with usually one drop transferred during each pulse. Combination of two levels of the current produces a steady arc with the exact axial spray transfer effect of the welding current below those required with the conventional spray arc welding. Because of the heat input is lower, the variation operation is capable of welding thinner sections than are practical with the conventional spray transfer. Arc spot welding. General arc spot welding is a method that is similar resistant to spot welding and riveting of various continuous gas metal arc welding process. Fuses two pieces of sheet metal together with a penetration penetrating entirely through one piece into the other. No joint preparation is required, other than cleaning the overlapping areas of the weld. The gun remains stationary while the spot weld is being made. Mild steel and stainless steel aluminum are commonly joined with the method. Electrogas welding. Electrogas is a variation of MIG welding process with the fully automatic high deposition rate method of welding of the butt or corner T-joints in vertical position. Electrogas variation essentially combines mechanical features of electroslag welding with MIG welding processes. Water-cooled copper shoes span with a gap between the pieces of the welding from the cavity of the molten metal with the carriage is mounted with the vertical column of the combination provided with the vertical horizontal movement. Welding head controls electrical spools are mounted with the carriage. Both of the carriage of the copper shoes move vertically upwards of the welding process. Welding head may also be oscillated with a provided uniform distribution of heat and filler. The method is capable of welding metal sections up from 1/2 inch to more than 2 inches in thickness in a single pass. Deposit rates of 35 to 46 pounds per hour of electrode can be achieved. Your MIG equipment. No. Different types of MIG welding equipment are available. The normal supply chain is manual. Each type of them must be consulted prior to the welding operation. MIG welding unit designed for the manual welding of small diameter wire electrodes using a spool gun torch unit, which consists of torch or figure 523 voltage control box, a welding contactor, a torch handling complete motor gear reduction unit that pulls the welding wire electrode from 4 inches diameter spool containing 1 pound of wire electrode mounted in the rear of the torch. Alright, so figure 523 shows your MIG welding torch, a pressure roll assembly, the spool enclosure assembly, and then the gun would be the nozzle holder, contact tube, lock screw, inch push button, 24-volt DC motor, feed roller, inlet and outlet guide bushings. And then we have, where'd it go? Okay. We just lost a page. I must have hit the wrong button. Well, let's keep going. I'm way out of line here. I guess I must have hit something really far away. Sorry about this, guys. Alright, here we go. Alright, this is your connection diagram for the MIG welding, DC welding, generator green, white, black, welding contactor cable, electrode cable, welding contactor, voltage control box, argon hose, black, white, red, green, 115 volt supply cable, blue, red, black, blue, orange, torch switch cable, voltage pickup, torch ground cable, workpiece. Alright. The basic size of the wire electrode is 3/32 of an inch to 3/64 of an inch and 1/16 of an inch. Many types of the metals may be provided with a welding wire electrode with the same composition and base metal. The unit is designed for use for the AC/DC conventional constant current welding power supply gasoline engine driven arc welding machine issue. The field of the units may be used with both the power source and welding source. Nomenclature of the torch. Contact tube. Figure 523. The tube is made with a copper as a hole in the center of the tube with a 100 to 200 of an inch larger than the side of the wire electrode being used. The contact tube with the inlet with the outlet guide with the bushings must be charged when the side of the wire electrode is in change. The contact tube transfers power from the electrode cable into the welding wire electrode insulated lock screw to provide secure the contact tube of the torch. Nozzle holder. Nozzle is made with a copper to dissipate with the heat with a chrome plate with the reflective heat. The holder is made with a stainless steel connected insulation material which prevents arc from being drawn between the nozzle and ground in case the gun comes in contact with the work. Inlet outlet guide bushing. The bushings are made with a nylon long lever long where they must be chained to suit the electrical sides when the electrode wire is changed. Your pressure roll assembly is a smooth roller under the spring tension which pushes the wire electrode against the feed roll, allows the wire to be pulled from the spool. The thumbness screws applies tension as required. Motor. An inch button. When the inch button is depressed, the current from the running of the motor comes from 110 volt AC DC. The rotor pulls the wire electrode from the spool before starting the welding operation. Trigger is depressed. The actual welding operation start with the motor supplied with the electrode spool with the required rated speed. The current of the rotor is supplied with a welding generator. Spool enclosure assembly is made with plastic which prevents the spark spatter from jamming the wire electrode from the spool. Small windows allow the operator to visually check the amount of the wire electrode remaining on the spool. No, if any reason the wire electrode stops feeding, the burn back will result. The triggers just press the welding contactor is closed, thereby allowing welding current to flow over the contact tube. As long as the wire advances through the tube, the arc will be drawn at the end of the wire electrode. Should the wire electrode stop feeding while the trigger is being depressed, the arc will then form at the end of the contact tube, causing it to melt off. This is called a burn back. All right. Your welding contactor, figure 524, with a positive cable over the DC welding generator connected with the cable coming out of the welding contactor. Ground cable is connected to the workpiece. Electrode cable over the welding contactor. Cable is connected with the welding contactor and voltage control box as shown. Your argon gas hose. The hose is connected with the voltage control box with the argon gas regulator over the argon cylinder. Electrode cable. The electrode cable enters the welding current relay connects over the argon supply line. Both of them go out with the voltage control box into the torch in one line. Voltage pickup. The cable must be attached with the ground cable that the workpiece supplies with the current motor during the welding over the trigger is depressed. Torch switch. Ground cable with the torch switch. Cable is connected with the voltage control box with the local. Grounding cable is connected with the case of voltage control box. Alright, operating MIG, starting to weld. Press the inch button, allow the wire to electrode to emerge from the nozzle until half inch of protrude beyond the end of the nozzle, which maintain the line. Switch on argon gas powered source adjusted properly. Operator may begin to weld. Welding of the open air protective shield must be installed. Prevent argon gas from being blown away from the welding zone, allowing the weld to become contaminated. Press the torch trigger that sends the current down with the torch switch cable through the contactor cable, closing the contactor. When the contactor comes close to the welding circuit for the generator, the welding torch is completed. At the same time, the contactor closed with the argon solenoid valve opens, allowing the flow of the argon gas to pass out of the nozzle shield of the weld zone. Lower the welding helmet to touch over the end of the wire electrode tube of the workpiece. The gun is held at a 90-degree angle to the workpiece, but pointed at a 10-degree angle toward the line of travel. To prevent overloading of the torch motor when stopping the arc, release the trigger and never snap the arc out of the by raising the torch without first releasing the trigger. 7. Welding continues along with the maintain with the trigger is depressed. Setting the wire electrode feed. The dial in the front of the voltage control box labeled the welding control. It is used to regulate the speed of the wire electrode. To increase the speed of the wire electrode being fed by the spool, turn the dial counterclockwise. The decrease of the amount of the resistance curve of the arc allows the motor to run. Allows the motor to turn faster. Turning the dial clockwise will increase the amount of resistance, thereby decreasing the speed of the wire electrode being fed from the spool. An incident of the wire electrode touches the work, and between 50 to 100 volts DC generated the voltage, picked up the voltage, pick up the cable to shun it back through the voltage control box into the resistor. There is this to reduce the current voltage 24 volt DC and sent to the torch motor. Fuses. The 2 ampere fuse is located at the front of the voltage control box and protects the control of the electrical circuit of the voltage control box. 1 amp fuse located at the front of the voltage control box protects the control of the torch motor. Installing wire electrode. Open the spool enclosure with the covered assembly with the brake of the pressure roll assembly. Unroll the straightened 6 inches wire electrode from the top of the spool. Feed the straight end of the wire electrode into the outlet bushing to the place of the spool with the mounting shaft. Press the pressure roller secure in the place. Press the inch button with the feed with the wire electrode until the 2.5 inch protruding beyond the end of the nozzle. Setting up argon gas pressure. Flip the argon switch over the front of the voltage control to the manual position. Turn the argon gas cylinder valve. Set the pressure of the regulator. Then, when proper pressure is set for the regulator, flip the argon switch to the automatic position. Or when manual position, argon continues to flow. When in the automatic position, the argon gas flows only with the torch trigger with the depressed. The stop of the flowing with the torch trigger is released. General polarity. The generator is in reverse polarity. When set on the straight polarity, the torch motor runs in reverse, withdrawing the wire electrode, causing severe burn back. Reclaiming burn back contact tube. Contact tubes are new with the 5 3/8 of an inch, along with the burn back for the curve with the 5 3/8 of an inch may be filed off. File a flat spet on the top of the guide of the tube. Place the drill pilot onto the contact tube. Then drill the contact tube figure for 3/64 of an inch contact tube. Use the number 46 and number 47 the drill bit. Our preventive maintenance. Keep all the welded spatter cleaned out of the inside of the torch. Welding in vertical overhead positions will cause spatter to fall down inside of the torch nozzle holder. Restrict the passage of the argon gas. Keeps all hose connection tight. Replace the feed roller. Remove the nameplate with the top of the torch. Then flathead screwdriver retainer from the feed roll mounting shaft of the contact ring of the feed roll. Place the new feed roll on the feed roll mounting shaft, making certain pins are protruding with the shaft and engage the slot of in the feed roll with reassemble the contact ring and nameplate. Alright, other welding equipment. 2 welding cables of sufficient carrying capacity with a heavy, tough, resilient rubber jackets are required. One of the cables should be composed of the fine copper strands to permit as much flexibility of the size of the cable that will allow. One end of the less flexible cable is attached with the ground lug or a positive side of the direct current welding machine. The other end of the work table, other suitable ground. One end of the flexible cable is attached with the electrode holder. Other end of the negative side of the direct current welding machine for straight polarity. Most machines are equipped with a polarity switch, which is used to change the polarity with the interchanging welding cables at the terminals of the machine. For the machines are not equipped with the polarity switch, for the reverse polarity, the cables are reversed at the machine. Alright, your electrode holders is usually an insulated clamping device for the holding of the electrode during the welding operation. The design of the holder depends on the welding process, which is used to explain below. Metal arc holder. This insulated clamp in which the metal electrode can be held with a desired angle. The jaws can be opened and means by a lever handle placed by a spring. Figure 525 shows metal arc welding holders. Atomic hydrogen torch. An electrode holder torch consists of 2 tubes insulated to handle throughout the hydrogen gas electrical current flow of the hydrogen supplied with a tube at the rear of the handle from which it was led for the 2 carrying tubes by means of manifold. One of the 2 electrode holders is movable. The gap in between this is the other holder is adjusted meanwhile by means of the trigger handle. Figure 526 shows your electrode section through the electrode clamp. The electrode clamps tungsten electrodes, the insulator trigger, and 2 conductor cable hoses. Your carbon electrode holders manufactured 3 specific types. One type of the holder, 2 electrodes, and similar design, the atomic hydrogen torch, but now has no gas tubes. And the second type, the single electrode holder, is equipped with a heat shield. And the third type, the high ampere welding, is water cooled. Alright, your accessories, your chipping hammer and wire brush. The chipping hammer is required to loosen the scale and oxide slag. A wire brush is used to clean each weld bead before further welding, showing the chipping hammer with attached to the wire brush, 527. Other welding equipment, welding table. Welding table should be all steel construction. Container of electrode insulated hook to hold the electrode holder. When not in use, it should be provided. The typical design welding table shown in figure 528. Clamp and back bars. Worker with welding should be clamped with the position. C-clamps are the clamp brackets. Block strips or backs of copper and cast iron should be available for use in back bars and welding light sheet. Aluminum making certain type of the joints. Certain carbon blocks, fire clay, other fire resistant materials should be also be available. These materials are used to form the molds and have molten metal with given limits for the build up of the construction. A mixture of water, glass, fire clay, carbon powder can be used in making the molds. Alright, goggles are green lenses shaped to cover the eye. Orbit should be available to provide glare protection from the personnel in and around vicinities of the welding cutting operation other than the welder. The goggles should not be used in actual. These goggles should not be actually used in welding operations. Are electrodes in their use general when the molten exposed to the air with the absorb the oxygen, nitrogen become the brittle and otherwise adversely affect the slag covered needle. It covers the need to protect the molten solidifying weld even from the atmosphere. The cover can be obtained with an electrode coating, which protects the metal from damage, stabilizing the arc, improve the welding way to be described below. Type of electrodes: metal electrodes may be grouped and classified: bare electrodes, light coated electrodes, shield arc, heavy coated electrodes. The type of depends on the specific property required for the weld deposit, include with the corrosion resistant, ductile, high tensile strength, and the typical base metal of to be welded position over the weld. Flat, horizontal, vertical, overhead. The type of the current polarity required. Classification of electrodes: American Welders Society classification number of series made to adopt the welding industry electrode identification system of steel arc welding is to be set up. E indicates electrode for the arc welding. The first two or three digits include the tensile strength of the resistance of the material forcing trying to pull it apart in thousands of pounds per square inch of the deposited metal. Third and fourth digit of the position 0 indicates the classification is not used. 1 indicates all position. 2 includes flat and horizontal. Position 3 is for a flat position only. Alright, the fourth digit indicates the typical type of the electrode coating of the typical power supply, alternating direct current, straight, reverse polarity. The type of the coatings, welding, and current and polarity position designated with the fourth and fifth, identifying the digit of the electrode classification are in Table 5.4. The number of the E6001 arc is welding arc of the minimum stress, the relief tensile strength of 60,000 pounds, and used all position, reverse polarity, direction, current required. Alright, the electrode identification system stainless steel arc welding is set up with the valves. The E electrode stands for E indicates electrode for arc welding. First three digits for the American Institute Steel Institute. The type of the stainless steel. Last two digits indicate the current position used. The number E30816 still indicates the system indicates the stainless steel type of 308 used in all position, alternating reverse direct current. Bare electrodes are made of wire composition required for the specific application. These electrodes have no coatings other than the required wire drawing. Wire drawing coatings have some slightly stabilizing effect on the arc, but are otherwise non-consequent. The bare electrodes are used with the welding manganese steel. Other purpose of the coated electrode but not required is an undesirable diagram of the transfer metal across the arc of the bare electrode shown in figure 529. 529 shows the molten metal transfer of bare electrode. Your light-coated electrodes have a definite composition. Light coating has been applied with the surface of washing, dipping, brushing, spraying, the tumbling, wiping to improve the stability characteristic of the arc stream. They are listed in E45 series with the electrode identification system. Coating generally serves the following function: to dissolve the reduced impurities of oxides, sulfur, and phosphorus. It changes the surface tension of the molten metal with the globes into the metal, leaving the electrode smaller and more frequent in the making, with the flow of the metal more uniform. And increase for the arc's ability to introduce materials readily ionized to change with a small particle with electrical charge into an arc stream. Some of the light coatings of them may produce a slag, but in quite thin, that does not act in the same manner with the shield electrode type of the slag. The arc action obtained with light electrodes are shown in figure 530. 530 shows the arcs obtained with a light coated electrode deposit, molten metal paste, metal crater, penetration arc core, light coated electrode arc frame. Shielded arc and heavy coated electrodes. Shielded arc and heavy coated electrodes have a definite composition coating that has been applied with the dipping of the extrusion electrode manufactured with three general types. These with cellulose coatings, those with mineral coatings, and those with a combination of mineral and cellulose. Cellulose coatings are composed of soluble cotton, otherwise forms of cellulose, small amounts of potassium, sodium, titanium, and in some cases add minerals. And the mineral contains consists of sodium, silicate, metal oxide, clay, other organical substances, combinations thereof. Cellulose-coated electrodes protect molten metal gaseous zones around the arc and slag deposit over the weld. Mineral-coated electrode forms a slag deposit only. Shield arc and heavy-coated electrodes are used with the welding steel with the cast iron hard surfacing the arc obtained with the shield arc heavy-coated electrode shown in figure 531. 531 shows the arc action containing shield electrode wire, shielded heavy coating gaseous state, projection sheath, slag, base metal welded deposit with molten metal, crater, and penetration. Alright, functions of shield arc and heavy coated electrodes. These electrodes produce the reducing gas of the shield arc over the previous Prevents atmospheric oxygen, nitrogen from containing the welded metal. The oxygen would readily combine with the molten metal, removing all moving alloying elements, causing the porosity of the nitrogen would be cause brittleness, low ductility, in some cases low strength, and poor resistance corrosion. 2. The electrodes reduce impurities such as oxide, sulfur, phosphorus, and the impurities will not impair the welded deposit. Provide substance to the arc, increase the stability, eliminate with wide fluctuations into the voltage so that the arc can be maintained without excessive spattering. Reduce the attractive force between the molten metal with the end of the electrode, reducing the surface tension molten metal by vaporizing metal coating cause of the molten metal at the end of the electrode to breaking up into fine small particles. Alright, 5. The coatings contain silicone, which will form a slack over the molten weld and base metal. Since the slag is solidified with a relatively slow rate, it holds the heat and allows the underlying metal to cool slowly, solidifying with a slow solidification of the metal and eliminates the entrapment of the gases and weld permits the solid impurements of the flow of the surface. Slow cooling has an annealing effect of the weld deposit. The physical character of the weld deposit modified by the incorporating alloy materials in the electrode coating. The fluxing action of the slag will also produce a weld metal, better quality, permitting weld at higher speed. The coating insulates the side of the electrode so that the arc is concentrated with the confined area. Facilities welding of the deep U and V grooves coating produced in the cup cone sheath at the tip of the electrode, which acts as the shield of the concentrate, directs the arc and reduces the heat losses and increases the temperature at the end of the electrode. Alright, storing electrodes. Electrodes must be kept dry. Moisture destroys the desirable characters of the coating, makes excessive spattering, leads to the formation of cracks in welding area. Electrodes exposed to damp air for more than 2 to 3 hours should be dried by heating a suitable oven of 2 hours at 500 degrees. After they have dried, they should be stored in a moisture-proof container, but bending of the electrode can cause the coating of the break loose of the core wire. The electrodes should not be used in core wire exposed. Alright, 532 show the electrode drying ovens, tungsten electrode, non-consumable electrodes for gas tungsten arc welding or TIG, wheel welding 3 types, pure tungsten, tungsten containing 1 to 2% thorium, tungsten containing 0.3 to 0.5 zirconium. Tungstens are electrode identify the type of titanium is marked green for pure tungsten, yellow for percent of thorium, 1% thorium, 2 for red for 2% thorium, brown for 0.3 to 5% zirconium. Pure tungsten is 99.5% the tungsten electrodes you generally use the less critical welding operation tungstens which are alloyed. The type of electrode relatively low current carrying capacity, low resistant contamination. Thoriated tungsten electrodes are 1 to 2% thorium are superior to pure tungsten electrodes because they have a higher electron output, better arc starting and arc stability, high current capacity, longer life, and greater resistant contamination. Tungsten electrodes containing 0.3 to 0.5% zirconium generally fall between the pure tungsten electrode and the thoriated tungsten electrodes in terms of performance. However, some indicate the better performance and contains in certain types of welds using AC power. Our finer arc control can be obtained with the tungsten alloyed electrodes is grounded to point. The electrode is not grounded that must be operated with a maximum current density to obtain reasonable arc stability. Tungsten electrode points are difficult to maintain. Standard direct current equipment is used as a power source for the touching start of the arcing. Standard practice maintenance of electrode shape. The reduction tungsten inclusions weld can be accomplished by superimposing high frequency current on a regular welding current. The tungsten electrodes allow the thorium and zirconium retain their shape longer than torch starting is used. 533 show the current electrode taper. Or the electrode section between the gas cup is determined by the type of the joint being used. For example, the extension beyond the gas cup with 1/8 of an inch might be used for the butt joints. Light gauge material will extend approximately 1/4 inch to a half inch might be necessary. Some fillet welds. Tungsten electrode torch should be inclined slightly with the filler with the metal to add carefully to avoid contact with the tungsten. This will prevent contamination with the electrode. Contamination does occur. The electrode must be removed, reground, replaced in the torch. Direct current welding. Welding current circuit may be hooked up to either straight polarity, reverse polarity. The polarity recommended for a specific type of electrode is established from manufacturer. The direct current straight polarity of the welding machine connects to the electrode negative workpiece and work positive electron flow through the electrode to the workpiece. For this, direct current DCRP or direct current reverse polarity welding machine connections are electrode positive, workpiece negative. Electron flows from workpiece to electrode. Shows the straight polarity generate pole switch workpiece. And then reverse polarity generate polar switch electrode reverse polarity workpiece. Alright, for both current polarities with the greatest power of the heating effect of the curve of the positive side of the arc, the workpiece, the direct straight polarity electrode is direct reverse polarity. For the others, given the welding current drop required for the large diameter electrode does the direct current straight polarity. For example, the 1/16th of the diameter pure tungsten electrode can handle 125 amperes of welding current using straight polarity condition. With the polarity reverse, however, the amount of the current will melt with the off the electrode containing the welding metal. Hence, 1/4 inch of the diameter pure tungsten electrode is required to handle 125 amps of the direct current reverse polarity satisfactorily and safely. However, the heavy coated electrodes with the composition of the coating of the gases produced may alter the heat conditions. This will produce greater heat. And negative side of the arc, another type of the coating will provide the most desirable heat balance of the straight polarity. Another type of the coating of the same electrode provide the more desirable heat balance of the reverse polarity. Through the different heating effect of influence not only of the welding action, but also the shape of the welding, obtain the direct current straight polarity welding produce wide, relatively shallow lead weld, direct current reverse polarity because the larger electrode diameter, lower currents generally employed gives a narrow, deeper weld. On other effect of the direct current reverse polarity welding is so-called plate cleaning effect with the surface cleaning action is called the electrons leave the plate by impacting the gas ion, striking the plate with the tend of the breakup. The surface oxide directly usually present. General straight polarity U for the mild steel bare light coated electrodes. Reverse polarity U for the welding non-ferrous metal such as aluminum, bronze, metal, nickel. Reverse polarity is also U for the same type of electrodes for making vertical overhead welds. Proper polarity with a given electrode can be recognized by a sharp cracking sound of the arc, while wrong polarity will cover the arc to emit hissing sounds. Welding be difficult to control. Alternating current welding will theoretically combination of the direct straight polarity and direct reverse polarity. This can be explained showing the three current waves visually, as shown in Figure 536. Half of each complete alternate current AC when direct straight polarity, and the other half direct current reverse polarity. Moisture, oxide scales, etc. on the surface of the plate tend to partially complete with the prevent the flow of current reverse polarity direction. This is called rectification. For example, there's current allowed in the reverse polarity direction of current flow would be similar in Figure 537. Shows a rectified AC current. To prevent rectification of the occurring, the common practice of the introduce the welding current additional high voltage, high frequency, low power current, high frequency current jumps gaps between the electrode and the workpiece pierces oxide film, thereby forming a path of welding current to flow. Superimposing high voltage, high frequency current welding current gives the following advantages. Arc may be started with a torch electrode with a workpiece. Better arc stability is attained. Longer arc is possible. The particularly useful surfacing hard-facing operations. Welding electrodes have longer life. The use of wired current range, specific diameter electrodes is possible. A typical weld current produced with a high current frequency stabilized AC shown in Figure 538 together with both direct current straight polarity and reverse polarity both for comparison. Alright, your direct current arc welding electrodes. Manufacturer recommendations should follow with the specific type of electrodes being used. General direct current shielded arc electrodes are defined either as reverse polarity for the straight polarity or both, but not all of the direct current electrodes can be used with alternating current. Direct current is preferred with many types of covered non-ferrous bare alloy electrodes. Recommendation from the manufacturer also include the type of the base of the which for the given electrodes suited with the correction of the pore fit-ups and other specific conditions. In most cases, straight polarity electrodes will provide less penetration from reverse polarity than for the reason of the permit greater welding. Good penetration can be obtained with either the proper welding condition or arc manipulation. Alternating current arc welding electrodes. Coated electrodes which cause either direct or arc current are available. Alternating current is more desirable while welding is restricted areas using high currents required for the thick section because of the reduced arc blow. Arc blow causes blowhole, slag inclusion, and lack of fusion in the weld. Alternating current is used for the atomic hydrogen welding and is over the carbon arc process is required with the two carbon electrodes. It permits uniform rate of welding electrode consumption. Carbon arc processes where one carbon electrode is used. Direct current straight polarity is recommended because the electrode is consumed at a low rate. are electrode defects with their effects. A certain element of the oxide presented with electrode coatings with the arc stability with effective electrodes of the composition uniformity, wire important factor control of the arc stability, then heavy coatings electrode completely remove the effect of the defective wire, aluminum oxide, which present consumable not exceeding 100% silicon dioxide, iron sulfate cause the arc to be unstable. Iron oxide, magnesium oxide, calcium oxide, iron sulfide to tend to stabilize. All right. When phosphorus sulfur presents electrode in excess of 400% will impair with the weldability because of the transfer of the electrode with the molten metal with very little loss. Phosphorus causes the grain with the growth brittleness, cold shortness, brittle with below red heat in the weld. These defects increase the magnitude of the carbon content, steel increase. Sulfur acts as slag, breaks up the soundness of the welded metal, causes the hot shortness, brittle above when red heat. Sulfur is particularly harmful to the air. Low carbon steel electrodes with low magnesium count. Magnesium promotes the formation of sound welds. And if the heat treatment given the wire core over the electrode is uniform, the electrode will produce welds inferior to those produced with an electrode of the same composition that has been properly heat treated. Alright, we're moving on to section 4, resistant welding equipment. I'm going to cut the tape there.